and I'll reiterate the question. Today we're going to talk about the massive ipart that I've assigned in 2402, and we're going to start from page 7 of the HAL V-Twin plans. It's the valve spring keeper pin, and what we're going to do is we're going to start with the standard IPT. Double click that. Now I'm going to start off with my standard part, and then I'm going to create my ipart from that. It automatically throws me, because I asked it to, into my XY sketching plane, and I'm going to first project the geometry of the crosshairs, the crossing planes in my view. And all I have a piece of drill rod. It's 0.63 inches by 0.24 inches long, so all I have to do is draw a circle. So I don't really need to project those two lines, but I'm in the habit of it. So I'm going to put in 0.063 here, and that's all that I need in this sketch. So I'm going to extrude it, and that's where I'm going to get a parameter for my length. Now if I double click on the dimension, it allows me to go into, if I right click on the dimension, I go to dimension properties. Dimension properties, this is the name of that dimension. I'm going to call this diameter, or DIA. Let's make them as short as possible so that we don't have to re-type them in a long format later on. So I'm going to make this diameter and say OK. And it stays the same, but if I double click this, or if I right click this and dimension properties, it shows me what that parameter is. So when I finish this sketch and I extrude, what does it tell me? It's fully constrained. Why is this not going off here anyway? If I hit E for extrude, and I'm extruding that, I could extrude it symmetrically or one way or the other way. But I'm just going to go in one direction, and that's 0.24 long. Now the way that I get the length to be a parameter is I'm going to type in length or LEN or whatever you want to use as your designator for your parameter equals. And that makes it a parameter. Anytime it's red, it's not a good input. When it turns to black, it's accepting it. So it likes that equals in there. So now if I go to change this, I have two parameters, the diameter, DIA, and the LEN. Now that I have this part, I'm going to go ahead and attach a material. So I'm going to go to drill rod. I hate this one, so I'm going to hit this down key. Did you guys find drill rod in here? High strength, low alloy. So that's what we're going to use right here. And that changed the material to look like polished steel. So I'm going to go ahead and save this. And when I save it, I'm going to save it as the ipart name, 0020 21111. I'm going to call it B, because I already have one in here. So that's the overall part. The different configurations, the dash numbers are going to come out of the table. I'm going to save this. And now I'm going to go to manage this, and this is how you have to have a part to start with to create an ipart from it. So I'm going to hit create ipart. And now I have DIA and LEN, and notice how I'd already put them in there for me. So as soon as I put my parameters in, it's going to try and put those in here for me. So that's the only thing that I have really here. In my member name, if I have my different, let's say I have my spreadsheet. So the first thing that I had you guys do is create a spreadsheet showing the differences in some of these configurations. This isn't nearly complete, but I got down to the wrist pin. So notice that I have different materials. Drill rod will be high strength, low alloy, so you want to put those in as inventor shows. So this would not be a column that I would want to make. I'm going to show you why. Here's my DIA column, so I'm going to make this DIA, but I've already got those columns in there. So as you have these different parameters in here, you don't have to put these in here again. Alright, so I've got several things with this, but a flange thickness is the next one. So what I'm going to do is I'm going to grab all these descriptions and I'm going to copy them. And then in Inventor, you have your table right here. So if you right click on your table, you can edit via the spreadsheet. So now look at my part number. Here's my member name. So I'm going to paste all my member names in there. Now I don't have to do those. Essentially everything that's in Inventor is a spreadsheet. That's the way it's reading it out. So I don't want my part number to have a B in there. So we're going to look at how to do that. So I'm going to save this and then I'm going to get out of it. So if I go back into my table now and double click on it, look what all I got. It actually copied it and pasted it right in there for me. So how many of these do I have? I've got all those configurations. Now what I was showing you in that presentation that I made on how to put the parameters in the sketch and how to put the parameters in the feature links is how to also set your options for your part number. So if I go to my part number, I'm going to leave it 21111. So this is my category, my base part number. I'm going to have a separator. So right here, right now, this is the way they're looking. Initial value is just, the separator is a dash. The initial value starts with -1, but it only has 2 digits. If I make this 3 digits, you can see how it changes. So if I say OK on that, it's actually added every dash number for me automatically. So you don't have to do that either. Okay, so I have a couple different diameters, and then I need to make the next part from this so that I can put that flange on there, or so that I can put those different features on there, right? Because those features are going to be suppressed. So if I go back to my Excel spreadsheet over here, the next one I have is a rocker arm roller pin. And if you look on your rocker arm roller pin on page 8, it has chamfers, it has a flanged in, and it has a C-clip kind of turned undercut. So there are many different things on here that are different. Let's look at this now. So it has no hole in it. It has a flange. It's 25 thousandths thick. It has a flange diameter. It does have a clip for a cut for that C-clip. And then I need to put those dimensions in there. Now if all my C-clips are the same size, which are all 18 thousandths and all .073, I'm only going to add or suppress these things. They're all the same. I'm either going to compute or suppress them because they're all the same size. So if you look on page 8 at the bottom, those turned undercuts are all the same thickness. They're all the same diameter. So all I have to do is compute or suppress. So if I put C in here and I put suppress in here, then I could copy this out to everyone. Copy this out to the spreadsheet. But yes or no doesn't work in there. Compute or suppress. C or S. Yes. Okay, so what we were saying is that the length of the shaft, the distance of that C-clip undercut on page 8 of every one of those bottom 3 parts is the same distance from the end. So it's essentially the length of that changes. So I have in my links for these, I have 0.214 plus 18 thousandths plus 0.03. So that's the entire length without the flange. So then the flange is going to add more length to that. That's the way that I set mine up. Okay, so let's come over here and let's change the diameter. So the rocker arm roller pin is diameter 125 and the length is from my Excel spreadsheet. Let's see if we can do this now. Won't let you paste in here. So we could do it if we went into the Excel. So let's do that. Okay, so let's right click on this and edit it via spreadsheet. Let's go right here and let's paste that in. So there's my length. So essentially what I'm saying is, let's go back to this spreadsheet. I'm just going to copy every one of these things. So far, so good. And let's go ahead and let's copy, if you remember which one's which, diameters. Now see those quotation marks? You're not going to know that. That's what it's giving me a problem with. So I'm going to go back to this one. And I'm going to paste over all of them. Now I'm going to take these out. So 0.125, 0.125. I was just saying that they were the same. Alright, so now we have all those. So I'm going to get out of this. Alright, so let's go to a different configuration. So now it's giving me a length that's different and a diameter that's different. Now I have to add the flange onto this end. So I'm going to select this part, create a sketch. It's already got the concentric reference. My flange diameter is 187. Now watch this. I can type it right into the dimension. So let's see if we can put an underscore. Yeah, it just doesn't like spaces. Flange diameter, 187. So if any of those changes, which they don't, not in these, but we may have one that changes later on, right? So let's go ahead and put that in. I'm going to extrude both of these shapes, and that thickness is 0.025 on all of them. Okay, I got that. So I need to name these. I'm going to call this shaft, and I'm going to call this flange. Because if I'm going to either compute or suppress something, I have to have a name on it, or I'm not going to know what it is. So shaft, I know kind of what that is. Let's get to the next point. We have some chamfers on both ends. So we're either going to compute or suppress those, right? And if we have this flange, it has to have the chamfer on the flange, or it won't compute. It can't formulate that. So let's do another thing. Let's go ahead and make a cut. So what are we going to do? A revolve cut or what? I'm going to make an offset datum. So I'm going to make a plane, a select on this, and then I'm going to drag it. So I'm going to drag it. Okay. So what it says is it's 30 thousandths. Negative. Okay. And then I'm going to sketch on that plane. Project the geometry of the circle and draw a concentric circle around that. So this is the inner cut. So that inner diameter we said was 0.73. And if I hit slice graphics, you can see into that. Now if I extrude, I'm going to select this. I'm going to flip it this side, and we said that that's 18 thousandths. I made it a join, right? So I'm going to edit it, make it a subtraction, and say OK. So now I can turn this off, visibility. So without, sometimes I think easier than a revolve. Okay, so then we have chamfers. So you can put the chamfers in at the last, or put the chamfers in at the first, whatever you want to do. So let's go ahead and put the chamfers in. Okay, so we have this part. And I'm going to call these my might want to make those different. Do we have other configurations with chamfers on the end of a post? Yeah, I see one right here. So we need flange thickness. If you look at the valve tappet, it has a flange and it has a chamfer down the bottom. So I'm going to make these two different parts. So if I take off this one, and I got that one, I'm going to call this one shaft chamfer. And then I'm going to make another one, and I'm going to call this flange chamfer. Right, and so then I can change those if I need to later on. And I can change the diameters, and I can add those parameters. So I've got that. I've got these. What is this? This is C-clip. I call this C-clip on my spreadsheet. So it's where I'd put a C-clip or an E-clip or whatever. Okay, so if I go back to the table, I'm going to edit via spreadsheet. Okay, so I have all these. What else do I need to put in there? Go back to my other spreadsheet. Flange thickness. Right? So I need to bring in that parameter. If I go here, that's cool and everything, but I don't have any way to add my parameters here unless I have to remember them. So I'm going to get out of this, and I'm going to edit the table just the way it was. So I'm going to go to flange. That is a suppression issue, right? Computer suppress. C-clip, computer suppress. Shaft chamfer, computer suppress. Flange chamfer. So it's got all those in there, and then all I have to do is change whichever ones that I want. So if I go to, where is that? Where are those quotation marks? You guys see them? It's got to be past inches or something that's killing me.